This morning we're going to talk about distributing information, which sounds like a very abstract topic, but it's actually one of the things you'll be dealing with the most when you build any kind of UI application. So especially when you build iOS apps, but even if you build desktop apps, one of the biggest problems that you're going to deal with is how do I move information from one point to another in my application? Which tools do I have available, and which ones should I use in which situation? On iOS specifically, we have a whole bunch of them. That's why this lecture is probably going to be a tiny bit longer than the last ones, but I want to give you the whole overview of the different options that we have. Some of them you maybe have heard about before. We're going to talk about delegation, which is kind of one of the core communication patterns that is used as part of iOS apps and also as part of the UIKit framework. We're going to talk about closures, which is just a general concept that we already touched upon that is available in almost every programming language. Then notifications is something you maybe haven't heard about yet. And lastly, we're going to talk about property observers and key value observation. So why is information distribution a relevant topic in UI apps? That's basically because they're super interactive. And you have multiple different interfaces where information comes into your app. That is either the UI, it's maybe the network, it's maybe the file system. And your main task is responding to these events and basically passing on information to relevant parts of your code and then responding to these events with some reaction on the UI again. So just a communication between the user interface and your business logic is basically one of the most things you'll be dealing with and basically spending a lot of time designing that interaction. There are a lot of different drawbacks and advantages of these approaches that I'm going to talk about over the next few minutes. One of them that is really important, in my opinion, is what we call code locality. So code locality basically means that you think about it actively, where should which code live, and you try to design your application accordingly. A common example is you want to download an image. Now, that download image is usually triggered by some kind of outside action. Let's say the user taps a button and you want to start a download. The solution that you might choose that doesn't really have great code locality would be put the whole download code inside of that callback of the button and then handle the response inside of that button as well. So we'd have one place where you trigger the network request because the button tap happened, and we also listen to the response. But in reality, when you look at your application, there's mostly one part that is responsible for listening for user interactions, but there's a totally different part of your app that is actually interested in the response of, for example, the network request that you trigger. So what you actually want to have is a tool where you can decouple that. And as in this example, you can say, download the image. That is an action that I'm going to trigger when the button is tapped. But the response to the downloaded images is actually handled somewhere else. Maybe in another view that is interested in actually displaying that image, or a part of your business logic that is interested in storing it to disk. So code locality is one of the important topics, and I'm going to mention the advantages and drawbacks regarding to code locality, but also other features for each of the approaches that we're going to talk about. So the first approach, how you could pretty naively communicate between two different parts of your code, is what I just called type-to-type communication. So let's say I have a view, you have a view controller, or any other type of two types of objects, and you want them to communicate with each other in a specific way. The easiest way would be you just have a reference to that other type. Let's say in a view, you have a reference to the view controller. And if you want to inform the view controller that, for example, a button was tapped, you just would know that the view controller has this specific method called info_button_tapped, and you could call it directly. That's the easiest way how you could get started. The drawback here is that this code here is tightly coupled. You now know in the user view that you definitely want to talk to a user view controller. It's one specific type, and you can't just replace it with a different view controller that maybe also would be capable of responding to this event. Another big problem is that you have the full interface available of this user view controller. So instead of having just the info_button_tap method, you actually have all methods that a view controller has available and all the ones that are inherited. For example, you can just access the load view method. You can access the view property. You can access the storyboard reference. These are all tons of things that the code that wants to communicate with this view controller doesn't care about. So if you have this in place, it's hard to understand which of the methods are actually relevant for the communication and which ones are just also available because you know specifically that you're communicating with this one type. So not an ideal solution, but an easy one to get started. Are the drawbacks here clear? Okay. So it's easy to use. That's really the only big advantage. But you have tight coupling. You don't really have a communication interface. You just have all the methods available that view controller has in its public interface. And it's also just useful for one-to-one communication. That's where delegation comes in. Delegation has the same idea behind it. You actually have one type communicating with another type. But instead of you knowing exactly which class or type you want to talk to, you talk through an abstraction which is called a protocol. So that protocol defines the relevant methods, and then any type can implement that protocol, and the class that wants to talk to it talks to it only with the methods that the protocol provides, not with all methods that a specific type actually provides. How would it look like? Same example, just instead of basically creating this direct connection, you create a protocol. Inside of that protocol, you put all the relevant methods that you want to use for the communication. So, for example, here the info button tapped one. And now whoever wants to respond to info button tapped can implement a user view responder protocol. So the same as in the other example, we can have the same view controller that implements this method, but now it also has to mark its conformance to the protocol that is relevant for the communication. So it implements user view responder. And on the user view side, you now no longer have a reference to exactly this class. Instead, you have a reference to anything that conforms to user view responder. So the type of the variable is now the protocol and no longer the concrete type that you're actually talking to. Now an arbitrary amount of classes could implement this protocol, and you could easily exchange which class is now actually communicating with the user view. Additionally, the only communication interface that is now available to this variable that stores the user view responder is this one single method. So the only method that can ever be called is this info button tapped one, which also makes it much clearer for other developers which methods you actually have as part of the communication between these two classes. So advantages here compared to the first one is we decouple the communication. That means we basically can replace the consumer just by having another class that implements the same protocol. We also have a tight communication interface. We can only use the methods that we actually explicitly added to that protocol that we created. We still have the same problem that it's only useful for one-to-one communication. And just as a reference, typically you would use the delegation pattern for what we call a lifelong connection. So for anything that basically, as long as the object is going to be alive, you want to listen to all events, then you would mostly use delegation. We'll see that there are some other use cases for more short-lived communication, where, for example, you just want to have the response for one network request, and then you don't want to listen anymore. Okay. Are there any questions around delegation and how it's better over the first example where we talk to the concrete type? Nope. Okay. Then let's go into closures. Closures basically provide a similar advantage that we can have a lower coupling. If we use closures, then we essentially have a function, for example, one that fetches the user details, and that function provides an argument that allows the caller to pass in a closure. Sometimes we can define a type for the closure to make the code more readable. That's what I've done up here. So what we're saying is we want a closure that will return an optional user, and the function that gets passed in doesn't have to return anything. So that means whoever passes in a callback has a chance to get a response of this network request. The cool part about it is that the class that declares this function and declares the callback doesn't have to know which class later will come in and actually pass in the callback. Doesn't have to know who's going to call the function. So again, any kind of class, any kind of type, any function could listen to the callback of this function, and it's a very flexible way of replacing who's listening to it. On the consumer side, would look like that. You have the API client in this case. You call the user details function, and you pass in the closure that you want to be called as soon as the response is available. So again, it's loosely coupled because we don't have to know who's going to come in and fill in this callback. All we have to know that is whoever fills in the callback has to provide a function that takes a user argument. That's what we defined up here. So there are some gotchas when you use closures. One is code locality. So as I mentioned, you might be inclined to just implement a callback exactly at the place where you call the actual function, and then put all the callback code inside of the closure. But if you have a lot of callback code, if there's like 100 lines of code that respond to the function, then what you end up with is 100 lines of code inside of view.appear. And that just doesn't look good. If someone looks at your code and they say, what happens if view.appear, and you see there's a network request plus the full response for the network request, then yeah, something's wrong with the code structure. It's just not a great way of structuring your app. So what you can do instead of passing in a closure here directly, you can pass in a reference to a separate function. So you can say, my closure is actually the function called received_user. Then you can put the function elsewhere in your class, and you pass in the reference by name. So once a callback occurs, this function is going to be called. It's exactly the same mechanism as this here, just that it allows you to place the code elsewhere. And the second thing you have to take care of when you work with closures is considering retain cycles. We're going to talk about memory management separately, since it's also a broader topic. But what can happen is that you can create what we call a retain cycle. Retain cycle means that two objects are pointing to each other and are keeping each other in memory. And that means that the memory of these objects will never be freed, even if these objects are no longer needed. That happens in this specific case because we're keeping a reference to this callback in a variable. So that means the callback is always stored as part of this class. And inside of the callback, we're referencing self. Now, if you remember closures, then you know that self, in this case, refers to the outside class. It actually refers to the enclosing scope of the closure. So now what we're doing here is we're keeping a reference to user view controller. And user view controller is keeping a reference to the callback. So now we have two strong references to each other. And that means these two objects will stay in memory forever. And if you allocate in large amounts of code in there, then a large amount of data, then you'll run into memory management issues and your app might crash. Seen that quite a lot throughout the summer. So what you have to do as a countermeasure is using unowned self as part of the closure. That here in the square brackets is what we call a capture list and allows you to define how you want to capture things of the surrounding scope. In this specific case, you say, I want to capture self, but I want to capture it as an unowned variable. Unowned basically means I don't want a strong reference, I want a weak reference, one that doesn't keep the other object in memory, one that just is like a pointer but has no memory management implications. And that means if the object is ever freed, then this reference will turn to null. We can talk about it more as part of the memory management lecture, but essentially this here will keep a weak reference that doesn't keep the other object in memory, and that breaks the retain cycle. So when do you use closures? Typically for short-lived relationships. So unlike delegations where you say, I set up this communication channel that's going to be used throughout the whole lifetime of the two objects. With closures, you say, I want to call this one specific method, and then I'm interested in the response. And after that, we no longer need to talk to each other. That's where you typically use closures. The advantage is we again have decoupled communication. We don't have to know exactly which type is going to talk to this class. And we also have a very tight communication interface. So we just have that one callback that can be passed in. So the communication between the two types is very clear. Two things to take care of is code locality. Make sure that you don't always put all the code for your callback directly inside of the closure. Consider actually calling a different function. And also be careful to avoid retain cycles. So notifications. Notifications is one of the things you maybe have not used before. Notifications are useful if you want to have one-to-N communication. So all the ones we use so far are usually used for one-to-one, where one type is talking to one another. Notifications allow you to broadcast information. And any class, any type in your app can actually subscribe to these notifications without that you have to know about it. How does it work? The API is provided through a class called NS Notification Center. You access the default notification center, and then you post the notification. Notifications are identified by name, so you pass in a string. Ideally, you use a string constant and not a literal string like here. And additionally, you can also pass on user data as an optional argument. And that is all that is required to send a notification, to broadcast it. And I'm going to show you in the next slide how people can register, or classes can register for these notifications. On the other side, you again use the NS Notification Center, and you call add observer. Then you pass in an instance of a class, for example, self. That's the most common case. that you, in this current instance, just want to listen to the notification. And then you also pass in what you call a selector. A selector is just a function name of the function that should be called when the notification is posted. Then you implement a function, and you also have to be careful to either inherit from NS object when you implement this class, or to mark the function with the @Objective-C marker. That's necessary because NS Notification Center is an Objective-C class, and it will only see Objective-C methods if you explicitly mark them with @Objective-C. Otherwise, they're Swift methods and they're not available to the Objective-C runtime, and then the features don't work. So that's just a short side note. But essentially, that is a pretty simple API, and it allows any class in your app to subscribe, which is a pretty cool feature. One thing you have to think about is that you shouldn't forget to unsubscribe. So there is no way of unsubscribing automatically. You actually explicitly have to call the unregister or remove observer method at one point in time. And you should do that either before your class gets deinitialized, or in case of, for example, a view controller, you should do it before your view controller disappears from screen. Otherwise, what happens is the notification center will remember that you are still registered, but if your object is no longer in memory when the notification is sent, then the notification center will try to access dereferenced memory. And then your app will also crash. Because it will try to talk to an object that is no longer allocated, and that's bad. So that's a tiny drawback of the notification center, because it happens to a lot of developers that they forget to unsubscribe. But yeah, keep that in mind. What are notifications used for? Really just for broadcasting information. If you have a one-to-one communication, then all of the previous technologies and techniques are better. The cool part is it's really easy to communicate with an arbitrary amount of different parts of your program without that you have to know up front who is interested in listening to the events. There are also a whole bunch of drawbacks. The first one is there's really no communication interface. The only thing you can do is you can post a notification, you can attach some data, but there's no type information about the data that comes along with the notification, so it's not really clear defined what the communication looks like. If you forget to unregister, then your app is going to crash. That's another downside, obviously. And it can also create dependencies in your code that you didn't think about beforehand. So if you imagine you work on a large team with 20 developers, and you provide an API that posts a notification, there might be people that you don't know about that added code that depends on that notification. And now if you 2 months later want to remove that part that posts the notification, you really don't know which other parts of code actually require to listen to this. If you actually have a function and remove the function, then the compiler can tell you that someone is calling this function that's no longer there. With notifications, because they just use strings, there's no way for the compiler to detect such a situation. So that's another drawback. So another way of communicating change and communicating data and passing it along are property observers in Swift. Property observers allow you to propagate information within an instance of a class. Some of you maybe used them in Swift before. They were pretty handy. You can add them basically to any property by adding a didSet or willSet block. And that block will be called as soon as the property is changed. So let's say I have a view set up that displays a user, and you want to update a label every time the user changes. Then you can do that with a property observer. You just implement didSet, and every time user changes, this is called. Then you update the label with the latest username, for example. That's really handy, but it's also only available within one class. But it's cool because it's easy to use, it's type safe, you know exactly which type of information you get. But because it's only available within the same class, it's not really applicable for a lot of scenarios. Okay, the last one I want to talk about are bindings and key value observation. Key value observation is a very popular API back from Objective-C. It's not super applicable in Swift, but if you ever look at Objective-C code or talk to people that have a bit of experience building apps for iOS or Mac, then you probably hear the term KVO. What it allows you to do is basically observe any property on any class without that the class has to know about that observation happening. So you can say, I have a user object somewhere else that's stored in a view controller that I don't have access to, but I want to be informed as soon as the username of that user changes. And then you will get a callback as soon as that happens. A pretty powerful feature. The API is really ugly when you use it from Swift because it just was not designed for that. So the way you start to observe a property is you call addObserver, then you pass in a string that is the name of the property you want to observe. Additionally, you have to implement a function called observeValueForKeyPath. There's only that one function that gets called for all observations. So all callbacks, doesn't matter how many properties you observe, go into here. It's also already pretty bad API design, but that's what it is. So what you have to do then is check which property was changed, and then you can extract the value. Also important to note, this will only work if you inherit from NSObject, or if you have a property that is marked with addObjective-C and addDynamic, because it's an Objective-C feature, and on Swift objects it's not available by default. So overall, it's not really recommended to use this with Swift. If you use Objective-C, then KVO is a cool feature, because it allows you to observe properties of any object, but in Swift it's really horrible to use. But there are some alternatives that I'm going to talk about on next slide. Yeah?
Does it mean you can use Delegation to like observe private properties?
You can also observe private properties, yes. Yeah. Cool. So yeah, a bunch of drawbacks that I talked about. Bad API, doesn't work on Swift classes. There's also, again, no type information for the changes that come. Basically because you have this one function that listens to all changes. Every change is always of type any object. So you again have to remember which type the property had, and then you have to cast. All of that is really horrible. The only good part is you can observe properties. But we have, in Swift you have an alternative for that, and these are third-party libraries that people built. If you went through the Summer Academy material, then you maybe heard of the Bond framework. That's the one that we used as part of the second tutorial in Mixogram. And what Bond does is it basically implements a Swift way of key value observation that is type safe, that works with Swift classes, and that is much more recommended to use inside of Swift. I want to briefly talk about the API. I linked to the YouTube video that has a lecture from the Summer Academy where I talk about this feature in more detail. But just as a reference for the people that didn't go through the Summer Academy stuff, basically the way you use key value observation with this framework is that you have to wrap every property that you want to observe into what we call an observable. If you did this Summer Academy, you might remember this being called dynamic, but the framework has been updated and some of the key classes have been renamed, so now it's called observable. Observable is essentially a container for a different type, and it adds a functionality that you can observe changes to that variable. So inside of the angled brackets, inside of the generic type, you provide the type that actually would be the type of the variable. So if you have an image and you want to make it an observable image, then you just place that into squared brackets. Then you can create an observable, and that observable is going to behave exactly like an image, except that when you want to change or access the image, you have to access the .value property. So that observable is a wrapper around whatever is stored inside, and if you want to access what is stored inside, you can do that through .value. So now if you want to change an image after it has been created initially, you say image.value new image, and because it happens inside of this container, the container is now able to tell all listeners that the change happened and can send a new image to them. From the consumer side, it looks like this. Second example from the Mixogram tutorial, we have a post, and a post stores a certain amount of likes. And we have a view controller, or in this case, a table view cell actually, that is interested when new likes occur or when likes are removed. What we can do is we can access the likes property of this post, assuming that it is an observable, and then we can call the observe function. Observe method, actually. And as part of the observe method, we provide a closure, and that closure will be called every single time when the likes change. So every single time when a like was added or removed, this is going to be called, and we basically can have code that updates the UI when it happens. Here again, I use unknown self to not capture the surrounding context and to avoid retain cycles. But overall, it's a cool feature. You can observe properties, and it's pretty easy to communicate change from the post class to the cell without that you actually have to call functions just by setting up this connection. Another cool feature that's part of that framework is that it provides extensions on a lot of UI code components. So for example, for a UI image view, you can bind the image property directly to the image view using the bond image property of UI image view. And that means you don't actually have to have any explicit code. You don't need any closures. You don't have to set up any code that updates the UI. All you do is set up this binding. And as soon as the image changes after the post, the image view will automatically update. And for other developers, when they look at this line of code, if they know the Bond framework, then this line of code is really expressive because it says, when this changes, update that. And there's no 5 lines of code that maybe are more difficult to read and understand. So in general, if you feel comfortable using such frameworks, I recommend it for UI programming. So bonds, what are used for? Observe changing values on other objects. So essentially the same as key value observation, but updated for Swift. It allows you to observe almost any property. Given that we have to basically change, we have to have access to the class that we want to observe. We cannot observe existing classes, so we can only observe classes we create ourselves. But that's just a minor drawback, I would say. A bigger drawback is that the communication protocol here is more implicit. So it's the same problem that you have with key value observation. You might not know exactly how many developers are listening to this property, and how many other pieces of code would be influenced by changing the behavior of this individual property. Whereas with delegates, you have a clearer expression of classes that actually set themselves up as a delegate of a different class. Here it is more implicit. So to summarize, I talked about delegation, which is like the old school Objective-C standard way of communicating between UI classes. This used as part of table views, collection views, everywhere over UIKit. We talked about closures, which is mostly used for networking, callbacks, and other short-lived communication. Notifications are one-to-many. So if you want to broadcast information, you don't care which clients are actually listening for it, then you can use these. Property observers and bonds are, the last one I talked about, are just useful if you want to set it up declarative connections between different parts of your code. When you want to say, when this updates, always update that. Usually when people explain it, they come up with a spreadsheet example. It's basically the best way of understanding how bonds work. You can basically set up a formula in a spreadsheet and say, when this cell changes, recalculate that cell and update it with the current value. So that here is a whole another topic we can talk about, programming with such frameworks, but I hope this gave you a good overview of the different options that you have. Are there any questions on any of these? Yeah?
For the bonding, is it all implemented in Swift?
Yes, the bond framework is all implemented in Swift. Okay. Yeah. And it's open source and free as always, so you can take a look at it. Cool. Thank you.